Welcome to the Future of Supply Chain, presented by Dynamo. Each episode, we sit down with leaders in the industry as we build the future of supply chain together. Let's get into the show. Here's our host, Santosh Sankar.
Hey, ladies and gents, welcome back to the Future Supply Chain Podcast. I'm your host, Santosh Sankar, and joining me today is Apeksha Kumavat, co-founder and chief engineer at Gatik AI. Welcome.
Thanks, Santosh. It's a pleasure to be here, and thanks for inviting me.
So, it's great to have you on, and I'm excited for your debut here on the Future Supply Chain. And for context, this season is all about AI intersecting supply chain, and really, I thought kind of you were maybe the best person in our portfolio to bring on related to this topic, because you all have become somewhat of a legend here for the work you're doing automating the middle mile. But with that, I want to jump right in and give our listeners here, like, what's your story? What's the Gatik story? How did it all come together to ultimately, I guess, be leading engineering at the preeminent autonomy company in the US or maybe even the world, depending on how you define it?
Absolutely. Thanks, Santosh, for that introduction. And just to give you a bit of a background about myself, I started my career in robotics and mainly AI and machine learning, specifically for navigation of robots. So this is indoors and outdoors. You can think about these machines essentially navigating different kinds of challenges within either indoor environments where you have a lot of like clutters and you have different kinds of furniture and equipments. It's still structured compared to when we talk about outdoor environments where you have a lot more dynamics, changes in environments, environmental factors, and things like that. So worked quite a while on different kinds of applications, specifically diving into the ML applications for specifically identifying different kinds of behaviors of agents around robots, making decisions and navigating through those kinds of environments. So that's where I come from. Worked in industry for a while before we started Gatik. So the story behind Gatik is all three of us, all three co-founders. My other two co-founders, Arjun and Gautam, we all come from robotics background. Arjun and I were lab mates during our time at Purdue University when we were like there for grad studies, and we worked on, as I mentioned, like different kinds of applications in robotics, and had a lot of intersection in the work we did. Gautam and Arjun, they come from a more conventional robotics background. If you look at the AI history, it all started from a more rule-based, more probabilistic kind of approaches that evolved into now what we see more data-driven, experience-based systems. So they bring in that perspective and that experience from the conventional robotics background. And when we worked together, we had a lot of overlap in terms of like the projects and the applications that we worked on. So after grad school, we went on to work on our own stuff. I went on to work with Ford Motor Company on their self-driving platform, was leading their systems team on the perception side, and had a lot of like I would say insights and how things were being approached in the industry, and what were some of the I would say in terms of like projections and how what this technology can actually do in the this was back in 2016, 17, what the technology would do in the next 5 years, 6 years. And I think where I was at, and I think same was true for Arjun and Gautam, we saw the potential of what this technology was capable of without over exaggerating or over promising on what it's not capable of doing at the moment, right? So making it more realistic and understanding the near-term benefits of this and how we can bring it into something that really solves a customer pain point was what went on in our heads when we came together to start Gatik. So this is back in 2017. All three of us came together with the vision of bringing the technology to a near-term application with the kind of approach of being more realistic, and not solving technology for just technology's sake, but really solving a pain point that was affecting the end consumer in a meaningful way. So That's where Gatik came to be back in 2017. The idea behind Gatik is that we are developing autonomous vehicles or autonomous technology specifically for B2B short haul logistics. What this means is delivering goods between known locations, warehouses, distribution centers for our customers. What allows us to do from a technology standpoint is constrain the kind of environments that we are going after. We have a lot of prior data, prior information about these environments because when we are doing deliveries between known stores or known locations, we exactly know where are we supposed to start, where are we supposed to end, how the end interaction between the vehicle and the store is going to happen. There is a lot of like prior information and insights that we can bank on when we are developing this product.
Mm. So three people deciding to go, use this technology, these kind of highly complementary experiences and disciplines,
Yep.
um, to deliver an autonomous solution. Three people in 2017. Where are you today? What's the size of the company, the makeup of the engineering organization that you lead today, just to give people a sense of the growth that's that you've
Absolutely.
experienced.
Absolutely. So, since 2017, we have come a long way. We are now a growing company of more than, I think, 120, 130 people. We are headquartered in Mountain View, also spread across different states in the North America, including Toronto in Canada, and Texas, Dallas, San Antonio are some major markets that we are operating in. From a team standpoint, from an engineering standpoint, like this is a mix of a lot of different fields and expertise, I would say. The autonomous vehicle technology brings in a lot of different kinds of, I would say, this is a key example of how robotics or how AI essentially like comes together from different kinds of fields. So you can think about this as more traditional robotics. Engineers who essentially know and deal with different kinds of integrations between the hardware, the sensors, the kind of mathematical and probabilistic methods that are being used to solve certain challenges. There are a mix of engineers who work deeply on the machine learning side, on deep learning side, to understand and interpret the large amounts of data. To support these, essentially, you have a huge effort from the infrastructure and machine learning operations, ML ops teams, and data ops teams. The amount of data that we gather from each of these stacks is in the orders of tens and hundreds of terabytes per day. So making sense of that, like curating these and actually making it available for the development, for training, for evaluation, and all of that. Is an integral part of the team's efforts as well. The other side of it is also systems and safety. So essentially understanding the systems from a larger standpoint, understanding the productization of it, and how does safety come into picture with all of this. That's also integral part of the engineering teams that we work together on. In terms of this is where the teams have came to, and from a company standpoint, organization standpoint, we have now been able to deploy across several markets, as I mentioned, like Texas, Toronto, Arkansas, and a lot more. So with the kind of deployments we essentially have with our customers. So these customers, the ones that we have announced are Walmart, Loblaws, Kroger's, Pitney Bowes, and there are several others that we have been working with and deployed with for a couple of years now. And with those kinds of experiences with these customers and across these geographies, has also matured like the kind of technology and the kind of approaches that we have been able to evaluate and validate on the roads, bringing us even closer to productization of this technology, right? In 2021, back in 2021, we were the first company to actually bring this kind of technology with no one on the driving seat on a commercial route doing delivery for customers. We did the same. This was back with Walmart, and then we did the same again with Loblaws last year in Toronto. So there's a lot of experience being gathered through these deployments and advancements that we are seeing in the product itself.
So you use two acronyms, right? AI ML, and our audience has a very kind of mixed set of understanding knowledge around kind of the technical aspects of technology. Would you be able to kind of describe that, explain that briefly for everybody before we move forward?
Absolutely, absolutely. So I think AI is the way we think about AI is any kind of system or essentially a program that allows us to mimic human intelligence. So this is a very broad field and a very broad concept in terms of what a system or machine can actually do, right? This need not be, when we think about AI, and this has been true for the past 70 years, as we think about something futuristic, AI was coined back in 1958 as artificial intelligence as a field, and it has always been futuristic since then. But what this field actually means is the attempt to be able to replicate some form, some part of human intelligence in some shape or form, right? Like it may not be the extensive way we think with the foundational, like things like consciousness and feelings and things like that, but being able to replicate certain tasks that human can do. So this field essentially encapsulates all the different kinds of methods that can go in terms of being able to replicate that human intelligence. You can think about a program that essentially has a bunch of if else or rules, which has nothing to do with data driven approaches, with a lot of like if else sentences. You can think about the old medical systems where you had disease and then a prescribed medicine for that. If it was a hard coded if else from a knowledge that was gathered from the field of experts. That's an example of artificial intelligence which was done a while back, right? Like, and now in that whole spectrum of different kinds of machines, you have this intelligence at different levels, right? Like you have certain intelligence that is being hard coded, and when you have to update that, a human needs to go in and actually update those hard coded thresholds in terms of what the knowledge means, right? What we are seeing now more and more is the data driven approaches, which is what machine learning is. Machine learning is a subset, is a smaller subset of what artificial intelligence overall represents. And these are the kinds of like algorithms within AI that allow us to improve the system's understanding or system's knowledge just based on the amount of data that we keep on feeding it. So this is a system that improves its accuracy, its performance based on its either interactions with the external world or with the data that it's consuming in general. So that's what high level, like what the difference between AI and machine learning is. It's essentially a sub part of that.
Yeah. So, with that, the world is in the middle of like AI mania since GPT was released last fall, and I've become a bit cynical of this trend chasing. And part of it is because I've had the privilege of meeting people like you and being an investor, being along for the journey, seeing that you are using, really advanced applications and techniques to deliver value. And I guess my question here is like, why all of a sudden all this hype? Because you founded the business in 2017. It was several years ago that you announced your collaboration with Walmart, and then it was a couple of years ago that you pulled the safety driver out. So, kind of, what's caused all this hype all of a sudden? You think?
Absolutely, I think um, the so AI has seen these kinds of like hype cycles before as well. I won't. I'll be honest. Like in terms of the technology behind ChatGPT or the more hyped up applications, the technology behind it, which is transformers, was released back in 2017. That was a paper publication. from Google Brains, and it essentially, like, if you look at that particular algorithm and that approach, it is remarkable, and it is in a sense a breakthrough in how we think about the architectures for deep learning models. So there is value, and then is I would say, a technology that needs to be appreciated in terms of what it has done to the industry. However, the I think the hype is more around the publicity and the application itself, around what the general audience thinks it can do, rather than what it actually is. There is, if you look at the basis or foundation of that the technology transformers, um, what it why it is so exciting is, the way those models have been architected. uh, the the fundamental pieces are not something that's they are not new. They are something that have been, like, it has been a process by which we have gotten to this point. But the way they were organized and the way that was architected, it allowed the industry to now use the computers, the kind of computers that we have, GPUs, and the amount of data that we could feed in to such models. It has changed that. It has allowed us to optimally use, more efficiently use the kind of compute that we have towards certain set of tasks, towards a certain set of applications. Now, if you look at the first application where that particular approach was proposed for, which is natural language processing translation. So that's where there is a lot of value in that kind of, like, approach. However, it's very nascent. Even that model, which was like 5 6 years ago, that was proposed, there has been a lot of variation that has been experimented with that kind of architecture. And the One of the other things that has also gotten a lot of, like, attention, and it's really useful, is this kind of approach now allows us to go multimodal in terms of data representation. So this is a change in how we think about representing data, how we think about inputting that data to learning models. So instead of, like, being constrained within domains, such as, like, the two huge domains within machine learning, which is computer vision, and the other side is natural language processing, being constrained to either images or videos, or being constrained to texts or speech, you have a way to now bring multimodality in terms of the knowledge gathering, and representing that to your models, and creating this somewhat generalized form of representation for the way the models consume the data. That is exciting, and I think that is where a lot of, like, the industry is in general, like, excited about, from the AI standpoint, the advancement in AI. But one thing is, and this is my, like, hypothesis, I think it's more around, like, how this is being perceived in the social media, and social media also, like, kind of, like, hypes it up, without getting into like, the actual details around what this can and cannot do, and the what this actually means for the industry, and why it is this why everyone thinks this is important. It's being perceived as this tool that can solve everything, or this essentially there have been talks around sentience and sentient AI and things like that, which is huge leap from what the model can actually do. It's This is where the hype essentially, like, comes from. It's a bit of a complex concept to understand, and what comes in front is more of the just the final, like, application that seems to be giving all the answers to what you're asking. But if you look at the accuracies and performance and all of that, there's a lot to be done to actually get to a point where it makes sense. There are hallucinations, there are problem of misrepresentations, there are problems of biases and things like that. So I think it's more around, like, how it's being perceived. The concept is being perceived with the applications that we are seeing right now.
Yeah. So, I guess kind of bringing it back to autonomy, could you walk us through how certain ML techniques are used in delivering kind of an autonomous experience? And maybe I'll leave it to you, kind of what you think the best example is. But perhaps something people can relate to, having either rode in a car or hopefully a lot of our listeners have driven a car themselves.
Absolutely. I think autonomous driving, if you look at the task itself, generally like it's thought about or broken down into three key like steps: sense, plan, and act. So you need to sense the surroundings, you need to plan in terms of what action would you take based on the world around you, and then act based on it. So the way robotics or any sort of like approach that's built for this takes these three key sub parts or sub like functions that need to be executed. If you're thinking about any sort of autonomy, this may be level 2 or level 3, where you have assisted driving functions, lane keep assist, or you might have adaptive cruise control. You're sensing something in front of you, or you're sensing the lane lines that are in front of you, and you're making a plan in terms of making a call in terms of like whether you want to shift right or left, whether you want to slow down or accelerate, and then acting based on that. The domain that we essentially, or the use case that we are building autonomous vehicles for, is level 4, SAE level 4, which is where you have all the levels before that, L2, L3, is where there is an expectation that if there was any malfunction of, or any issue or any situation that the vehicle is unable to handle, or the system technology ADAS is unable to handle, the driver is liable and is responsible to take the control back. So these kinds of systems essentially give an alert and fail, or they essentially add a warning for the driver, and the driver is supposed to take back the control in less than a second. So these are level 2, level 3 systems. If you talk When we think about level 4, the expectation is in certain geographies or certain constrained domains, the vehicle is able to handle all situations and fails gracefully or safely without causing harm to itself or others, without giving back the control to the driver in the driving seat. So all the kinds of edge cases, failures, warnings, and all of that need to be handled by the vehicle itself. Either it comes to a stop in lane, it pulls over, it slows down. Then multiple different kinds of minimum risk maneuvers that can be done. But that's the baseline for what an L4 vehicle, level 4 vehicle needs to do. So this is where, when you think about self-driving autonomous vehicles, a lot of people think about the Teslas or ADAS features that they might have in their vehicle. However, there is a backdrop to all those kinds of technologies that if they fail, the driver is the one who is supposed to take back the control. And contrasting that with L4, the expectation is there's no one in the vehicle. Now, if we think about the ML techniques that go into these kinds of systems, mainly the machine learning has been, or data driven approaches have been thought about mainly in the perception prediction systems, where you're perceiving, you have cameras, you have lidars perceiving the world and classifying these into certain classes and objects, like, am I seeing a vehicle, am I seeing a pedestrian, am I seeing a traffic light, what is the state of the traffic light, and all those things. There have been traditional approaches to these as well, but what we have seen with machine learning approaches is these systems improve quite a lot, and have certain nuances, and are able to mimic certain human intuitions as we keep on feeding it more and more data. So there is value in terms of having these kinds of data driven approaches in either perception, decision making of the vehicles. There are certain approaches some of the companies in the AV industry have been taking, where the entire task of driving, or sense, plan, and act, the entire task of driving is a huge giant like deep learning network, where you feed in the cameras on one end, and then you have steering, brake, and throttle on the other side, and you're just training it with human driving data. These kinds of system, theoretically, if we think about the system, are possible, but this needs a huge amount of data, number one, to train. And the biggest like challenge with deep learning or data driven models is you need to validate these, or you need to be able to explain the decisions that they take in systems like these. The way I think about it, it's like monkey driving. It does most of the time the right thing, and you feel that yeah, it's doing the right thing, but you don't know why it's doing it. It's trying to mimic something, but when it doesn't do the right thing, you really don't know why it didn't
There's
do
no
it.
explainability effectively.
Exactly. So that's the main drawback that we have suffered from data driven approaches so far. From Gatik's perspective, what we have been able to do is, given our known route, fixed route use cases, we are able to break down these deep learning models into modular architecture, small models that are supported or encompassed with more deterministic conventional methods, creating a hybrid architecture that allows us to actually like poke in and see what these models are producing. We need exponentially less data for that, and that has been one of the the success stories in terms of why and how we have been able to actually remove driver out from some of our routes with our customers.
So to wrap us up here and bring us home, my last query is you talk about explainability, and um, I think a lot of the criticism out there around AI powered products is the inability to go diagnose why certain things happen, whether positive or negative with regards to outcome. How should creators think about this? Whether you're developing AVs, GPTs, whatever it is, like how should the makers think about observability and transparency?
Yeah, I think in a lot of the systems that are being that we are seeing right now, the functionality is coming first, and then the thought around like how do we contain it, or how do we actually think about observability or explainability of these models. With transformer networks, there is a side of like looking into the attention networks, which can be visualized in some form or the other. So there are talks around that, but it's still quite crude in terms of how much you can actually like rely on those as the true sense, or even like as the model scales up, as the amount of data scales up, it's very difficult to maintain that level of explainability. So um, I think it depends on the application. From my perspective, it depends on what's the level of tolerance in terms of inaccuracies that your application can sustain. It cannot be a generalized statement around a lot of different, like there is value in some of the advancements and functionalities that are being enabled through these models, but we need to be mindful of what application are we using this for, and does this application require a certain set of like, is it highly like in terms of autonomous vehicles, we cannot really risk being a certain percentage short, 95% short. The other 5% is catastrophic. We need to be really sure about like what this means for that application. Certain applications can do away with certain lesser accuracies and things like that.
Well, with that, Apeksha, thank you so much for joining us here. Love to highlight the types of things that are happening across supply chain, and in this instance in our portfolio as it pertains to this kind of new AI wave that we're all in the midst of. So,
Absolutely.
with that, appreciate your time and the wisdom.
Thanks, Santosh. It was great chatting with you.
Cheers.
Cheers.
Thanks for watching. Follow us at dynamo.vc for all the latest episodes. We'll see you next time.